Example number 7, draw the shear and moment diagram for the beam shown in the figure. For the reaction at the support, since we have here cantilever beam, we have the vertical reaction at point A. If this is point A, and of course the end of this uniformly distributed load is the point B, and this is the point C. We have here the AY, AX, and of course the moment at A. For the resultants of this uniformly distributed load here, it is just the area of the rectangle. We have the length of 4 and the magnitude of 60, so that's 4 times 60, and this is equal to 240 kilonewton. So let's solve for the reaction of the supports. If we are going to summate forces horizontal is equal to 0, taking the direction to the right as positive, then we have here AX is equal to 0 kasi wala naman siyang kalatan. And summation of moments at point A is equal to 0, taking the clockwise direction as positive. Then we have here the moment at A, we assume that it is counterclockwise, so that is negative. And this 240 kilonewton here will rotate clockwise, so it's positive 240. Multiplied with the moment arm. The moment arm is just half of this 4 here, so that's 2. And this 265 here will create clockwise rotation, so that's positive 265 multiplied by the distance of 6 meters. And this couple here at the free end, which is 1,350 kilonewton meter. So that's positive because it is clockwise, and this is equal to 0. So solving for the value of the moment at A, that is equal to negative moment at A plus 240 times 2 plus 265 times 6 plus 1,350 is equal to 0. Shift solve equals, and we have here 3, 4, 20. So we have 3, 4, 20 kilonewton meter. And if we are going to summate forces vertical is equal to 0, taking the upward direction as positive, we have here the AY, assume directed upward, so that's positive. This 240 here is downward, so it's negative 240. We have the 265 here downward, so that's negative 265. And itong couple na to ay hindi kasama kasi we are summating forces vertical, so this can only be considered here in summating for the moment, and this is equal to 0. So AY is equal to 240 plus 265, and that is equal to 505. So this is 505 kilonewton. So AY is equal to 505, and this moment at A here is equal to 420 kilonewton meter. Since we already had computed for the reaction of the support, so drawing na natin yung ating shear and moment diagram using the area method. So for the shear at point A, this is just equal to the reaction AY, which is equal to 505 kilonewton. So we have here 505, and the shear at point B is just equal to the shear at point A minus the area of the uniformly distributed load from point A to point B. And we have here 505 minus the area of the uniformly distributed load, which is equal to 240. This is equal to 265 kilonewton. So, meaning dito ay meron tayong 265 kilonewton. So, since this is degree 0, so dito sa shear diagram natin, we have degree 1. So, this is just a line. And the shear at point C is equal to 265 plus the area between B and C. So, since wala ka namang area dyan, that is just equal to 0. So, meaning this is just constant na 265. So, straight line lang. Yan. And of course, this 265 here minus yung load natin na 265. Therefore, ang shear natin at C will be closed. So, 0 na siya. And this is now the shear diagram. How about the moment? So, for the moment at A, we have here negative 3420 kilonewton meter. Ito yan, yung moment at A. So, dito ay meron tayong negative 3420. And the moment at B is just equal to moment at A plus this area 1 here. So, i-assume ko to na area 2 yung isa. So, moment at B is equal to negative 3420 plus, bakit plus? Kasi positive itong mga area na to. So, area 1, that is just the area of the trapezoid. So, we have here the distance of 4 and the average of the bases, that is 505 and 265. So, itong side na to ay 505 at ito ay 265. Ito naman yung kanyang height. So, we have the moment at B is equal to negative 3420 plus 4 times 505 plus 265 over 2. And this is equal to negative 180. So, we have 180 kilonewton meter. So, ito yun siya. This is negative 1880. Now, since this is degree 1, we are expecting na degree 2 yung curve natin dito. But, applying the idea of the dYIX, this is decreasing, no? So, gagamitin natin yung dy. So, decreasing, bebend natin yung y-axis. In this case, ito yung y-axis natin kasi ito yung origin. This is in quadrant 1. So, this is our curvature. Okay, and this is a degree 2 curve. And the moment at C is equal to the moment at B plus area 2. So, yung moment at C is equal to negative 180 plus the area 2, that is just the area of the rectangle, 265 yung height, and then yung distance na to is equal to 2. So, we have here 2 times 265. So, yung moment at C is equal to negative 1880 plus 2 times 265. That's negative 1350. So, this is negative 1350. Since this is degree 0, so we are expecting degree 1 here. No? So, this is just a line. So, we connect the 1880 to 1350 using a line. And this will be closed by the moment 1350 here. So, plus 1350, meaning the moment at C will be equal to 0. And this is our moment diagram.